Good morning, everyone. In the last class, yes. In the last class, we have discussed about polyhedrons, and we have discussed after that about convex and concave polyhedron also. In the polyhedron, if you all remember, we have discussed that if you take these polygons, you can see this is a cube. The polygons used to make this cube is a square. Plus, if you remember, we have discussed about this. You can see all the polygons used to make this cube are squares. Second thing to be a polyhedron was the what do you say? Okay, that was a different thing. Okay, so this is a cube, cuboid, and this is a suppose prism. I think it is a triangular prism. Let's see the next one that we have done. Then we have discussed about why these are not polyhedrons. Class, please tell why sphere, cylinder, and cone is not a polyhedron. We have discussed it yesterday also. Please tell. Because in the definition of polyhedron, we ourselves have written that a polyhedron is formed when many polygons join at the edges. And here you can see, no, just that is not the reason. This is not a 2D figure. They are also 3D only. Just cylinder is 3D, cone is 3D, sphere is 3D. Still, they are not polyhedron. The reason is different. Please tell me that. Anyone? Why sphere, cylinder, cone are not considered as polyhedrons? Please tell. Class, please answer. Because of the Yes, because of the curved surfaces. Very good, Kriti, Hiteshri. Because they are not made up of polygons only, there are curved surfaces in that. So that's why we don't consider them to be a polyhedron. Okay. Now you can see this cuboid is a polyhedron. This figure is also a polyhedron. This is your prism, a polyhedron. This is also a polyhedron because it is made up of all the polygons attached together on their edges. Now let's see the next concept that we have studied yesterday, convex and concave polyhedron. If you remember, I told you in the last class we have studied about convex polygon and concave polygon. In convex polygon, the diagonals are all inside. No diagonal is going outside. Similar is the case with convex polyhedron. Here also, if you try to join two vertices, you will find that the line is coming inside the figure, or you can say no line is going outside the figure. Similar here also. Then we have these two figures. You can take, if you join this vertex with this vertex, the line joining is coming outside. That is why it is known as concave polyhedron. So these are type of prism. Shaurya. Okay, Shaurya. Okay, sorry. I will take that also. Don't worry. Now, then we came to the concept of what is regular polyhedron. In regular polyhedrons, there are two conditions. Class, please tell me one by one. What was the first condition to be a regular polyhedron? Please tell. What was the first condition to be a regular polyhedron? All faces should be congruent. Harshul, all faces should be congruent. If you are taking a equilateral triangle, all should be equilateral triangle only with same dimensions. Okay, no difference at all. And what was the second condition? Please tell me. This was the first condition. What was the second condition? Please tell. So, what is the difference between equal and congruent? They are almost same only, but still it is fine. Okay, they are same only. Now, class, please tell me what was second condition. Okay, Ananya is saying all vertex should be made up with equal number of edges. Fine. Actually, we should see the vertex is made by how many faces. So if you take this vertex, suppose the back one, let me call it B. you can see this face, this top face and that side face. Three faces are joined together to form this vertex B. And we have considered yesterday also in this example that although point A is having three faces and point P is having four faces, that is why this figure was not considered as a regular polyhedron. Class, I hope it is fine for everyone. Please confirm. Okay. Now, after that, we came to the concept of prism and pyramid, in which pyramid was very easy for you because you were able to compare with your Egypt pyramids. Now, tell me, how will you name these pyramids? Tell me the name of first this pyramid. First, tell me the name of pyramid. Harshul, I can unmute everyone, but the problem is disturbance is there when I unmute everyone. They don't mute themselves. Okay, class. To name a prism, we need to see the base. The base over here is sorry pyramid. The base over here is a triangle, so we call it triangular pyramid. What do we call this one, class? If this is a square, suppose if this is a square, we will call it square pyramid. Okay. What about this prism? In prism, how to name? Please tell. In prism, how to name? Yes. In the prism, the condition that we have studied is the top and bottom should be congruent and the lateral surfaces should be a parallelogram. Okay. So in this also we take this base. It is a triangle over here. So we call it triangular prism. What about this, class? Although the common name is cuboid, what is the name of this figure with the concept of prism? Please tell, what is the name of this figure? It is a rectangular prism. Very good, Ananya, because not cuboid prism. Just you have to see the base. The congruent base over here is a rectangle, so we'll call it a rectangular prism. Okay. Now let's come to the next topic. We have to find these things. In a cuboid, how many faces are there, class? Please tell. In a cuboid, how many faces are there? First, there are six faces in a cuboid because six flat faces. The screen is blank. Darpan is saying, Darpan, please join again. Maybe some issue at your side. Tell me the number of vertices, class. Tell me the number of vertices. There are 8 vertices. Number of edges is 12. Yesterday we have seen this thing. Now, if you do f plus v, that is 6 plus 8, what will you get? You will get 14. And if you do e plus 2, you will get again 14. So you can say there is a relation. These two are equal. So I can say f plus v is equal to e plus 2. Class, can I say this thing? Please tell. We are getting that f plus v is coming equal to e plus 2. That is, they are equal. Now, triangular pyramid. Anyone? How many faces are there in a triangular pyramid? I think triangular pyramid means the base is a triangle and upside there are three those things. Show figure. Okay, 1 second. This was your triangular pyramid. Please tell how many faces are there? Okay, Vardhan. There are 4 faces in a triangular pyramid. Very good. How many vertices are there? Please check. In this triangular pyramid, how many vertices are there? Okay, same to same. 1, 2, 3, 4. 4. Now comes the next question. Number of edges. Please tell the number of edges. This is 6. So let us again check the relation. F plus V is coming out as 4 plus 4, 8. E plus 2 is again 6 plus 2, 8. So we are absolutely correct while finding the faces, vertices and edges. Class, good. Now let's see triangular prism. Let's see triangular prism, that is this one. Let me erase this. Please see, this is your triangular prism. Tell me how many faces are there? How many faces are there? Top and bottom. Please find. Very good. Okay, just you have a confusion. Please try to observe. Try to observe the figure. Hiteshri, try to observe the figure. Again, Kriti, very good. Shreya, very good. Ananya, very good. There are five faces. One top triangle, one bottom triangle, two, and then three faces. Five. There are five faces in this triangular prism. Then comes the number of vertices. Please check the number of vertices. 1, 2, 3, 4, 5, and 6. There are 6 vertices. Now the number of edges, class please check. Number of edges, 1, 2, 3, 3 here also, 6, 7, 8, 9. There are 9 of these. Now please check, f plus v is coming out as 11 and e plus 2 is coming as 11. So we are absolutely correct. Now the remaining two parts you can try on your own as your homework today. Okay. Now, so we have got this relation is known as Euler's formula. This formula or this relation was what you say interpretation. While writing all these things, Euler interpreted that f plus v was always coming equal to e plus 2. So he got this formula, f plus v minus e is equal to 2. This is the formula given by Euler, and this formula is very useful. In some cases, you know only faces and vertices, you can easily find the number of edges. So it is a simple linear equation. Class. Now let's see 10.3. Sir, for polyregular hadrons, for polyhedrons it will work, not regular only. For all the polyhedrons, this formula will work. Let's see one by one the questions. Question number 1 is, can a polyhedron have for its faces three triangles? Can you form a polyhedrons with three triangles? Please tell. Class, please confirm. Can you form a polyhedron with three triangles? No, we can't form a polyhedron with three triangles because it won't be a closed figure. Now, what about four triangles? Can we form a polyhedron with four triangles? Yes, because the example we all know. What is the example of that figure with four triangles? What do we call it? What do we call the figure with four triangles? Above only we have studied. Very good. It is a pyramid. A triangular pyramid is the example of this figure. Now third one is a square and four triangles. Is it possible to have, the example here is triangular pyramid. Okay. A square and a four triangles is also possible. And what is the figure form? Please tell. Again, the figure form will be a pyramid only, and the name of pyramid will be what? Tell me the name of pyramid. The name will be square pyramid because the base will be a square, and the name is square pyramid. Fine. Question number 2, is it possible to have a polyhedron with any given number of faces? Think of a pyramid. Is it possible to have polyhedron with any given number of faces? Not possible. No? We have to check actually. Then only it will be a polyhedron. Good. Now question number 3. Which are prism among the following? Please tell class. Is figure number 1 a prism? Please tell. We have studied in a prism we should have congruent base and top. and in this case the top is pointed. In this case the point is pointed, so it is different. And second thing, to be a prism is the lateral surfaces should be, class, we have studied the lateral surfaces of a prism should be a parallelogram. So that's why this is not an example. Wrong. What about this one? Yes, this is a prism because the top is a hexagon, the bottom is a hexagon, and all the lateral surfaces, all the six lateral surfaces are parallelogram. Class, we can check the top and bottom are hexagons and all the lateral surfaces are what? All the lateral surfaces are parallelograms. That is why this unsharp pencil is an example of prism. But if you sharp the pencil, it will not remain a prism. I hope you got my point. If you sharp this pencil, it will not remain a what you say, prism. Okay, the third one is a table weight, which is a shape of square pyramid. It is not, because the top is not same as bottom, first of all, and second, the lateral surfaces are triangle, not parallelogram, so it is not an example of prism. But this is an example of prism because top is square, bottom is square, all the lateral surfaces are parallelogram. So yes, yes, it is a prism because Saurabh, the top and bottom are same, and all the lateral surfaces, that means the side surfaces, are rectangle only. That is why we can consider the fourth part as a prism. I hope it is clear to everyone. Okay, fine. Now question number 4, you need to realize on your own. I'm just giving you a hint, class, or I'm asking from you. They are asking, how are prisms and cylinders alike? They are trying to ask, how are prism and cylinders alike? Okay, let's do one thing. Try this question number 4 on your own today. Tomorrow we will discuss it. Okay. You need to understand how you can, what you say, relate a prism and a cylinder. You have to relate a prism and a cylinder. Then you have to relate pyramid with a cone. You need to understand what should be done. No, 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 Kriti, that is not the answer. Both are solids is not a good answer for this one. You have to understand. Okay, so there is no sides of its base become larger. Okay, you try it today on your own. Tomorrow I will tell you if it is needed. Okay. Question number 5, is square prism same as cube? Class, please tell. Can we say a square prism is same as cube? Yes, we can't say because we never know. See, square prism means the base is square, the top is square. But what about the lateral surfaces, class? Can we surely say that the lateral also square? It can be a cuboid. Yes, we are sure it is a cuboid, but we can't say surely it is a cube. The reason being, we never know the lateral surfaces are a square or rectangle. Although we know that top is square, bottom is square, but we don't know about the lateral surfaces, so we can't say surely it is a cube. Okay. Now we will verify the Euler's formula and you all will help me in that. For that, you need some sort of understanding of this figure. Class, tell me how many faces are there. Please tell me how many faces are there. Try to understand. Okay, Hiteshri is giving the answer as okay. Some are saying 6, some are saying 8, some are saying 5. Okay. You have to consider the back also. The back is not visible over here, but you need to consider that also. Although we are not able to see that, but you have to consider that. There are 7 faces, one top, one bottom, then we have 3, 4, 5. 6 at this end and 7 at this end. So there are 7 faces. Now the number of edges, please tell. Number of edges, please tell. Okay, Joel, good. The number of edges, please tell. On the top you have a pentagon, on the bottom you have a pentagon, so that means 5 plus 5, 10. Try to understand like this: top is a pentagon, bottom is a pentagon, so 10. After 10 you have 11, 12, 13, 14, and that one 15. So edges are 15. What about the vertices? Please tell. How many vertices are there? Top is a pentagon, bottom is a pentagon. How many vertices are there? 10 vertices are there. Okay, good. Now tell me, is it following the Euler's formula? Tell me, is it following the Euler's formula? Okay, the formula is what? F plus V equal to E plus 2, if I'm not wrong. Okay, let's put the value. F is 7, V is 10, E is 15, and that is 1. So LHS is equal to RHS. The formula is verified. Formula is verified, the figure is correct, and it is a polyhedron also. Similar, you can try for this one on your own for all those things. Okay, and similar way you can try question number 7 and 8 also. You can try. They are asking, can a polyhedron have these many dimensions? You just need to check in the formula. If you are getting the same formula back, sorry, if you are getting LHS equal to RHS, then this polyhedron is possible. If they are not same, the polyhedron is not possible. Okay, with this I am stopping over here. I'm stopping the recording.